Okay, today's segment is called Solving Polynomial Equations in Factored Form. All right, it's on page 377. Solving Polynomial Equations in Factored Form. Let's see, a joke for you today. A dentist and a manicurist had a rough marriage. They fought tooth and nail. A dentist and a manicurist had a rough marriage. They fought tooth and nail. All right, I'll see if I can find a better one. What do you call an Irishman who bounces off the walls? Rick O'Shea. That one's pretty good. Ricochet. I'm not going to lie, I like that one. Ricochet. Let's see. That's not any good. No, that one's really dumb. Can't do that one. Did you hear about the dog that barked at a really low frequency? The dog that barked at a really low frequency. You call him a subwoofer. Oh, hey-oh! A subwoofer. Okay, anyway, let's get started. All right, so solving polynomial equations in factored form. Page 377, now moving to page 378. Here's the core concept. If the product of two real numbers is 0, then at least one of the numbers is 0. Okay? That's pretty simple. If I told you that x times y equals 0, you know by rules of multiplication that either x equals 0 or y equals 0, because 0 times anything is 0. Okay? If I told you x times y equals 0, either x is 0 or y is 0. Okay? Keep that general concept in mind. It's what we utilize to solve polynomial equations, is that concept. All right, so here's our examples. Example number 1, solve each equation. So in this first equation, am I off the board there? Let me rotate this just a smidge. In this first equation on page 378, it says 2x times x minus 4 equals 0. 2x times parentheses x minus 4 equals 0. By rules of multiplication, what that means is either 2x equals 0 or x minus 4 equals 0. So you set both of those terms equal to 0 and solve for your options. You will have two options, right? So I say 2x equals 0 or x minus 4 equals 0. And now I do my algebra. For 2x equals 0, I divide by 2, and I get x equals 0. That's one option for an answer. Or x minus 4 equals 0, add 4 to both sides, x equals 4. So my possible solutions are 0 or 4. If you plug either one of those into this equation, you will see you will get 0 for your answer. Okay? 2 times 0 is 0, so that makes it 0. Or 4 minus 4 is 0, and that makes it 0. Okay? All you do is you set the two things equal to 0 to solve. Okay? All right. Second one, x minus 3 times x minus 9 equals 0. So set both of those equal to 0. X minus 3 equals 0, or x minus 9 equals 0. Add 3 to both sides. The first option gives me x equals 3. If I add 9 to both sides, the second option gives me x equals 9. So my two possible solutions for the second equation is x equals 3 or x equals 9. Because if you substitute either one of those numbers in for x in the original equation, you're going to end up with an answer of 0. I want to encourage you, please, have your book open to this page or the copy that I made for you in Schoology open to this page so you can follow what I'm saying. Okay, it's page 378. Monitoring progress, 1, 2, and 3. As always, what I want you to do is get a piece of paper and a pencil out. Please check your ability to understand what we're doing and do problems 1, 2, and 3, and pause. Okay, so let's come back. The first one says x times x minus 1 equals 0. Set those both those terms to 0. So either x equals 0, that's done, no problem, or x minus 1 equals 0, add 1 to both sides, x equals 1. So our two possible solutions for this problem is 0 or 1. All right. Number 2. 3t times t plus 2 equals 0. So set both terms equal to 0. 3t equals 0. Divide by 3 on both sides. T equals 0. Or t plus 2 equals 0. Subtract 2 from both sides. T equals negative 2. So your options for this are 0 or negative 2. Either one gives you the answer of 0. All right? And the last one says, number 3, z minus 4 times z minus 6 equals 0. Set those both equal to 0. Z minus 4 equals 0. Clearly add 4 to both sides. Z equals 4. Or z minus 6 equals 0. Add 6 to both sides. Clearly z equals 6. So your answers are 4 and 6. Those are your two possible answers for this polynomial equation that is set equal to 0. Pausing. All right. Let's go to the next page. Solving polynomial equations. These are like special equations, all right? Example 2. 2x plus 7 times 2x minus 7 equals 0. So we're going to set those both equal to 0 as you see here in the example. 2x plus 7 equals 0. And 2x minus 7 equals 0. And you get the exact same answer for both except for the minus sign. So in this instance you have negative 7 over 2, which is negative 3.5. Or on this side you have positive 3.5. All right? Set them both equal to 0. When you have these special equations, the answer is the same except for you have a plus minus. All right? All right. B says x minus 1 squared equals 0. Notice here, you set x minus 1 equal to 0 and x minus 1 equal to 0, the exact same thing. Your only answer is x equals 1. And lastly, you've got one that has 3 polynomials. X plus 1 times x minus 3 times x minus 2 equals 0. One of those 3 terms equals 0. So set them all equal to 0 to see what our options available are. If you do x plus 1 equals 0, that means x equals negative 1. If you have x minus 3 equals 0, that means x minus 3. And if you have x minus 2 equals 0, that means x equals 2. Very basic. I think you guys are catching on. If not, we'll work it together in class. Monitoring progress. 4, 5, and 6, please. Complete 4, 5, and 6 with what we just did. Now is the time to pause. Okay, number 4, I have 3s plus 5 times 5s plus 8 equals 0. So set both those terms to 0. 3s plus 5 equals 0. Subtract 5. 3s equals negative 5. Divide by 3. and that's what s equals. Negative 5 over 3, or 5s plus 8 equals 0, subtract 8. 5s equals negative 8, divide by 5, or s equals negative 8 over 5. So those are your two options, negative 5 over 3 or negative 8 over 5. It's pretty basic algebra as long as you grasp the concept, okay? All right, number 5 says b plus 7 squared. So when you set that, you just go b plus 7 equals 0 and b plus 7 equals 0. As you can tell, there's no need to work out both of them. They're exactly the same. Just work out 1, subtract 7. b equals negative 7 is your answer. Okay, b equals negative 7. And lastly, I've got this threesome here, d minus 2, d plus 6, and d plus 8. Put each of them equal to 0. d minus 2 equals 0. Clearly d equals 2. d plus 6 equals 0. d equals negative 6. And d plus 8 equals 0. And d equals negative 8. Okay? Easy peasy, lemon squeezy. All right. We'll work on some practice sheets together in class this week, so if you're confused a little bit, I think it won't take you long to catch on. All right? Example 3. Find the greatest common monomial factor. So this says factor out the greatest common monomial factor from 4x plus, or 4x to the fourth plus 24x cubed. I think we've kind of been doing some of this when I've wanted you to reduce things. So what you do is you look at this term and you say, what is common to both of those terms that I can factor out? Look at the numbers first. I have a 4 and I have a 24. So 4 clearly goes into 24 6 times. So I can factor out a 4. That leaves me with a 1 plus a 6. I'm not going to write the 1 because the 1 goes away. Then I have x to the fourth and x to the third. The greatest common factor between those is x to the third. I have 3 of the x's here, 4 here, so I can take 3 out over here. 4x cubed, it leaves me with x plus 6. So now I now have factored out that monomial, okay? 4x cubed outside leaves me with x plus 6. And you want to do this so when you go to solve, you set those equal to 0 and you can solve for the answer. Okay? All right. Monitoring progress. Find the greatest common monomial factor from 8y squared minus 24y. This is at the bottom of the page, page 379. You can clearly see that. Okay? 8y squared minus 24y. Take a minute, factor that out. Shouldn't take you long. Pause. Okay, so I have 8y squared minus 24y. So look at the numbers first. I have 8 and 24. You all should know by now I can factor out an 8 that's common to both. Okay, pull out an 8. That leaves me with a 1 here minus a 3 before I get to the y's. Okay, so I'm just going to write that like that. Now I have a y squared and a y. The greatest common factor between the two is 1y here. So I pull out a y on the outside. I'm left with y minus 3. Okay, so it's 8y times, in brackets, y minus 3. That's factoring out a polynomial. Not a big deal. You got your homework to do it. We'll work at in class tomorrow. You guys will be fine. I promise. I think that's it. Let me just double check. All right, last thing, I'm sorry, there's an example here I want you to show. It's called solving equations by factoring. Solving equations by factoring. So the first one says solve 2x squared plus 8x. 2x squared plus 8x equals 0. the first thing you need to do is recognize that you can factor this. I can pull a 2 out, and I can pull an x out of both terms. If I pull out a 2x, that leaves me with x plus 4 equals 0. All right, because there's a 2x in here and a 2x in here. That leaves me with 1x left and 4. And now I set those equal to 0. 2x equals 0. Divide by 2. X equals 0. Or x plus 4 equals 0. Subtract 4. And x equals negative 4. So my two answers here are 0 or negative 4. The next one says 6n squared equals 15n. All right, 6n squared equals 15n. You got to do one step first. You got to subtract 15n from both sides because you need a 0 on one side. Subtract 15n. I'm left with 6n squared minus 15n equals 0. Okay, 6n squared minus 15n equals 0. Now what I need to do is factor. So the common factor between the 6 and the 15 is a 3. And then I can take out 1n from both of those. So I can factor out 3n. It leaves me with 2n minus 5 equals 0. Okay? I just factored out the common factors between the two terms. I can take a 3n out of 6n squared, which leaves me with 2n, because 3n times 2n is 6n squared. And I can factor out a 3n out of 15n, and all it leaves me with is a 5, because negative 5 times 3n is negative 15n. And now I have those equal to 0. Now I just solve. 3n equals 0, divide by 3, n equals 0, or 2n minus 5 equals 0, add 5, 2n equals 5, divide by 2, n equals 2.5, or 5 over 2. I know I'm going through it relatively quickly. We will reinforce it tomorrow. Please work on your homework and with us together in class tomorrow. The concept algebraically is not challenging and you should be fine. All right. Now I think that's it. Let me see. Oh, monitoring progress. Excellent. So we have 8, 9, and 10. Please go ahead and work on these and pause. Okay, the first one, number 8, says a squared plus 5a equals 0. What's common between those two terms is just an a. So I can factor out an a. Leaves me with a plus 5 equals 0. So I have a times a plus 5 equals 0. Set those both equal to 0. First one's easy. A equals 0. That's done. The other one, a plus 5 equals 0. Subtract 5. And a equals negative 5. So my two solutions are 0 and negative 5 for number 8. All right, number 9, I have 3s squared minus 9s. 3s squared minus 9s equals 0. My common factors between those two are a 3 and an s. Pull out a 3 and an s. That leaves me with s minus 3 equals 0. So 3s equals 0, divide by 3, s equals 0, or s minus 3 equals 0, s equals 3. So my answers are 0 and 3 for my possibilities. 0 and 3. And again, you can always multiply these to see if that works out for you. Last one, 4x squared equals 2x. 4x squared equals 2x. Again, we need to do the first step. Subtract 2x from both sides, and you get 4x squared minus 2x equals 0. You need to rewrite it first. Then look at your common terms. I can pull out a 2x from both of these terms, 2x. So I pull the 2x out, that leaves me 2x minus 1 equal to 0, and now I solve. 2x equals 0, divide by 2, x equals 0, or 2x minus 1 equals 0, add 1, 2x equals 1, divide by 2, x equals 1/2. Okay, so your two possible answers for number 10 are 0 and 1/2. And now I know that I've got there. I'm not worried about this arch. We're at the homework page. I know I went through this fairly rapidly, but it's because I'm confident you all can grasp this. We'll go over it in class. We'll do practice sheets. You can always schedule one-on-one if need be. Have a great day. See you tomorrow.